In this lesson, we are going to be talking about mean and standard deviation. Your first thing we're going to talk about is the mean, which you've done before. Remember that mean is your average. Whenever people talk about the average of something, they should be taking the mean. It's one of the measures of center, so it's kind of goes along with mean, median, and mode are all measures of center. And to find the mean, you add the values up and divide by the total number of values. So not something you haven't done before, but this formula might look a little new to you, so I kind of want to show you this. To find the mean, this right here is called x bar, and that's a sample mean. There's another variable that's used if it's a population mean, which we'll get into stuff like that a little bit later. But if the data is coming from a sample, so not from the whole population like a census or something, they'll use x bar as the symbol. So that's what that x bar is. And so that's a sample mean. And then this symbol here is a summation symbol, so that means to add. And so this is a really, I want to call it fancy way of doing the mean formula, because we know mean is adding the numbers and divide by the total number. Here this is saying to find the sample mean, so x bar, you should find the sum of all the x's, so that's every value, and then divide by n. N would be your total number of data values. And n always equals that. They use n often for that, so that's pretty normal. So for us to actually apply that, we're just going to do one problem quick, because I know you guys have done this before. Remember that to find the mean, we don't have to list them from least to greatest for mean like we would for median. So we just go ahead and put a plus sign between all these numbers. So on my calculator right now, I'm going to add up all these numbers, and then I'm going to divide by how many total there are. So I have 48, 51. I'm not going to pull up my calculator online because I think you guys can probably handle this. Oh, and I just hit enter every single time. That was really dumb. Sorry, I didn't put the plus sign I was looking up. Let's add them. Okay, when I add them all up, I get 893. And then I divide by the total number, so I count these. 1, 2, 3, 4, 5. There's 15 total. That's my n value then, so this would be an example of an n. I divide them by 15. When I take 893 divided by 15, that gives me my sample mean, which is x bar. And we round to hundredths if we're not specified, remember? So my mean for this is 59.53. Even though my data values aren't given to me in decimals, we always leave our mean as a decimal if it becomes one, and that's very common that it is. So the average, even sometimes it might not be an average that could be, like we'll say the average number of children each family has is 2.6. Well, no family has 2.6 kids, right? But we still report that as the mean because we're saying it's closer, the average is closer to 3 than 2 then. You're giving more information by giving that extra decimal. So we never round means to be the same as our data. We round it to the nearest hundredth, unless they ask you otherwise. The other thing we're going to talk about, which is something you haven't worked a lot with, is standard deviation. Standard deviation shows the variability or the spread of the data. The best way I think to describe standard deviation is to think of your grades. When you are given the mean for a test score and you want to learn about the standard deviation, let's say that my mean test score is a 75. That's a C, right? If my standard deviation is 10, that means that the average amount of spread between them is 10. So like there's going to be a spread between 65 and 85. So there's a big difference between a 10-point spread in grades, isn't there? So if my standard deviation was 10, this value here would be 1 standard deviation away from the mean. This value would be 2 standard deviations away from the mean. This would be 1 standard deviation away from the mean, because remember this is x bar right here. That's my mean. This would be 2 standard deviations away from the mean. And so the spread here, if we were looking 2 standard deviations from the mean, would be a score of 55 to 95. That's an F to an A. That's a really big spread, isn't it? Now think if I gave a test and my mean, my average, was still a 75, so we'll keep this, but my standard deviation was 2. If my standard deviation is 2, then 1 standard deviation would be 73, 2 would be 71, this would be 77, and this would be 79. So now here my range between 2 standard deviations away is a lot smaller. It's from a C- to a C+. So the smaller your standard deviation, the more clustered your data will be. This is what I mean by clustered. These are all in the 70s. They're really close together because my standard deviation was 2. In my first example I gave you, I was much more spread out. Here, I went from 55 to 95 because my standard deviation was 10. So the smaller your standard deviation, the more clustered your data. The higher your standard deviation, the more spread out it would be. Think of it in terms of the histograms we've been doing. You'd see that spread there. So they call that the variability or the spread of the data. It also measures the average distance of the observations from the mean. So if my average test score is 75 and you score a 73, you know you're just a little bit below average. If you know the standard deviation is 2, that's not so bad. If you score a 95 and my mean is 75, you know you're way above average. It helps us compare things. Another way they use standard deviation quite often is when you are little and you're going to the doctors, they always tell you what percentile you are in, and we're going to study percentiles, but they'll tell you, like my kids, of course, because Mr. Beeford and I are huge, our kids were always in the 90th percentile, and my daughter actually went over 100%, so she was like way above the average. So we knew they were above average in weight and height. Now, you'll actually probably hear a lot of kids in Minnesota are above average, because as a state, we are a little bit above average compared to the rest of the nation. We have those good German, Norwegian backgrounds, and we're big people. And so we might be taller than other kids in other states that maybe have some nationality in their background that happens to be shorter people. Whatever that is, I'm not really sure. So those are where you'll see this in your everyday life. And that's why we want standard deviation. We like to use things to compare ourselves to others or to see where we are compared to the norm. The norm would be like our mean. Where's the average? So here's an example that you have for how we use standard deviation and how it's calculated. All of these, it says you and your friends have just measured the heights of your dogs. So here's all these dogs, and you can see their heights are the red. That's where their height is. So not the top of their head, but like the heights of their shoulders. So the heights of the shoulders are listed there. So we have those 5 data values. To find the mean, they add them up and divide by 5. So our mean is 394. So this green line here shows where the mean is. So you right away, if you have this dog, you can see, oh, my dog's just a little bit above average. It's about normal. If I see this dog, ooh, my dog's above average. Look at that. They're quite a bit above average. Look how much they're above average they are. This dog, ooh, they're a little bit below average. Well, how below or above average are they? That's why we use the standard deviation. So here is the line I just drew. This is actually finding the difference from the mean. So to calculate the standard deviation, you take your data value minus the mean. So see where we have here? They took 600 minus the 394, and we got 206 right here. So that's what they did there. And then you find what's called the variance. What's the variance, you ask? That's the average square distance. Variance is not used a lot. If you're taking AP Stats, we'll use it a little bit more, but we won't use it a ton in this class. So to find the variance, you're going to square each distance. So this was the distances that were listed in the last problem, 206, 76. You square that number, and then you add them all up. That's this number right here. Then we divide by the total number minus 1. So n minus 1 is the total. So there's 5 dogs, so 5 minus 1, that's where they got that 4. So when they did that, this is the variance. So that's the average squared distance. What we're going to look for is the standard deviation. So after you find the variance, and you don't have to write all this down, I'm sorry, I should have mentioned that. This is just kind of talking through it. After you find that, you have the standard deviation. So you take the square root of the variance. So the average distance, one standard deviation away, is 164.71. So by using standard deviation, we have a standard way of knowing what is normal and what is extra large or extra small. So here, I see that one standard deviation away is these blue lines. So that's me adding 164.71 to the mean and subtracting 164.71 to the mean. And when I look at that, that's one standard deviation away. So I can see that my Rottweiler here, that's what this is supposed to be, huh? Rottweiler, he is more than one standard deviation away from the mean. So he's like extra tall. And this little doggy here, he's extra short, right? If I'm within one standard deviation, we don't really know a lot about that yet, but that's what we're going to study. There is, with a normal distribution, there are some percentages we can use to see just how normal we are, how many people should be in that category. And they use that quite often, actually. So now we are actually going to do our own standard deviation. Here is the formula you're given for standard deviation, and this will always be given to you, so you don't have to have this memorized. The first thing you do, you'll notice it says x minus x bar. Remember, x bar is your sample mean, so you will take x, which is your data value. That's your data value you're given. So the height of the dog's shoulders, and x bar is your mean. We'll call it sample mean, though. Let's use the proper terminology, huh? Sample mean. So you take your data value minus your mean, and you square it. And then, so here's the squared, and then you add them all up. Then you divide by n minus 1, so n is your total number, right, of data values. And then you take the square root of it. So that's what I just did with the dogs. We're going to actually apply that to our own problem now, so we can do one standard deviation by hand. So it says find the steps above to find the standard of the data from number 1. Standard deviation should be in there, sorry. So I knew number 1, we already did the mean, didn't we? We got 59.53. So from number 1, the mean, x bar, is 59.53. So for me to find the standard deviation, I have all my data values here. The first one you'll notice on the problem, you have the data values on your worksheet. But here's 48, so you'd copy those all in there, all copied exact, not in order, it's fine. So as we go through, we will take 48 minus 59.53. And we get negative 11.53. Then you'll go 51 minus 59.53, negative 8.53. And then we're going to fill this whole table out. I'm going to give you time to do that. But since I have this number on my calculator already, I know the next step is to square it. So I'm going to go ahead and just before I hit and do the next problem, like do this one, I'm going to go ahead and hit squared. So when I get 48 minus 59.53 equals, I get the negative 11.53, and then on your calculator hit squared equals, and you'll get 132.94. So I want you to fill this whole table out. So you go ahead and pause the video right now, and then I want you to square all the numbers, subtract them, square them, and see what you get for that. And you can check if you get the same answer I do. Alright, hopefully you got your whole table filled out. You got the same answers as me. And now you'll see, step by step you go through, it says sum here. So we're actually going to add all of these numbers up, and that's the sum we're looking for. So when I added all of those up, which you could easily do on your calculator, you should get 1143.72. And then we divide by n minus 1. Well, if I count how many numbers I have here, I have 15 numbers, right? So I'm going to divide by 14 in this case. So when I take 1143.72 let me just write it out here, divided by 14, I get 81.69. So this is an example of my variance. And then to get my standard deviation, I take the square root of that number. So the square root of 81.69 is 9.04. So this right here is my standard deviation. Now, this, hopefully you can see how this is kind of a monotonous process. I mean, that was a lot of work to get one answer, wasn't it? And it's very easy to make a mistake on this because, well, there's all these numbers you got to punch in. What if you copy something wrong? So we're actually going to do the same problem on our calculator and see that we get the same answer. Just to make sure. We've already turned the diagnostics on, I believe, in a different lesson. So you should already have that on, so you should be good. Yeah, because we did it last time to do our 5-number summary. We did that before. So now that we have this on here, I'm going to go ahead and enter. So I go to Stat, Edit, once you've done your calculator stuff right. I'm going to clear this list. And then I'm going to punch all these values in. So 48, 51, 46, 54, 51, 62, 55, 67, 55, 64, 62, 60, 71, 73, 74. Alright, how does that look? So now to find my standard deviation, I'm going to go to Stat, I'm going to go over to Calculate, and I'm going to calculate my one variable statistics, which we've done before. So when I hit enter here, there's my mean. So see the X bar, that's 59.53, which is what we got. And then the standard deviation is actually this SX number. So right here, which if I do round to the hundredths, excuse me, it's 9.04. So there we go, 9.04. So we do get the same answer. So that's how you could do it. And you may do it, I'm going to have you do some by hand tomorrow just to learn the process, understand where it comes from. And then we'll use our calculator for some on your homework. And then by the time you take the test, I'll let you choose which one you want to do. If you have any questions, make sure you let me know.